Good evening. Welcome to the week 12 live session, the last live session for this course. Hope you can hear me and see my screen clearly. Okay, let's get started. So today we have a couple of doubts that I got in the previous week, as well as a lot of problem solving from the week 11 and 12 parts. So what I've done is, wherever necessary, I've put a recap there itself. We will not do a detailed recap of this week's course contents. And if you have any doubts after this live session on something, you can post it on the discussion forum. I'll try my best to answer it in 2 or 3 days. So this will be the last live session for this course, just clarifying. Okay, let's get started. So in week 12, we looked at the following concepts. So again, this was about efficient neural network training and inference. So we looked at training and backpropagation, which we had started looking at in week 11 itself. And then we looked at matrix multiplication and some optimizations that are specific to it. We also looked at the concepts of neural network pruning and sparse matrix operations. So in today's architecture, a lot of GPUs have hardware level support for sparse matrix operations. So this is also very relevant. We also looked at the compressed, the CSR format for storing sparse matrices. So we'll go through all of these while we do our problems. But before that, let's get started with, I think there's just one doubt. So this was from question 13 of week 1. So let's go through it once. For a processor with a cache memory, let C be the cache access time, M be the miss penalty, and H be the cache hit rate. For non-cache processors, the memory read time is 10 clock cycles. For a cache miss, the typical time to load a block into the cache is 20 clock cycles. For a cache hit, the typical execution time is 1 clock cycle. Assuming that for 20% of the instructions, there is a requirement for an additional data read or write, and the hit rate for both data and the instruction cache are 90%, what will be the improvement in performance using a cache processor instead of a non-cache one? So without options, let's straight away look at how we solve this. So first, if you don't have cache at all, right? That's what is asked. So here you're asked about the improvement in performance when you're using a cache processor versus a non-cache one. So first, let's start from here. If you don't have a cache, then what is your performance going to look like, right? So that would be the memory read time, and this would be there for all instructions because you don't have a cache at all. Additionally, for some instructions, as it says here, 20% of the instructions, there is an additional read write, right? So we will account for that too. So I think the solution that was given to you uses 100 plus 20. I'm using 1 plus 0.2, but because you're dividing both of these quantities, it doesn't really matter, right? So so memory read time is 10 clock cycles, and then this is for all instructions. This is the extra portion for this 20% of instructions. So this is what is given to you. I've solved it in a slightly different way. Either way is fine, right? Now let's move to the second part of it, which is your with cache part, right? So if you have a cache, your effective access time, this is a usual formula that all of you know, hit rate into hit time plus miss rate into miss penalty. So your hit rate is given as 0.9, and again this is for both caches. So 0.90% of the time it's going to take you just 1 clock cycle, and 10% of the time when you have a miss, it's going to take 20 clock cycles, right? So this comes out to be 2.9. So and then when you're looking at the time with cache, it's instead of your memory read time, you will basically have effective access time. That's the only difference. The rest of it remains the same. So for 20% of the instructions, you have this overhead, which is the read write part of it. So 2.9 is your effective access time, and then you'll multiply it by 1 plus zero point 0.2. I have not put in the final these things here because this and this basically get cancelled, so it comes out to be 10 by 2.9, which was 3.448, which is the answer given to you. So I've just put this here for reference. I'll remove it so that it doesn't confuse you. So basically this is taken in percentage here, and I have taken it as a fraction of 1. Either one is fine in this case because I are anyway going to divide the two. Okay, hope this is clear. Okay, with this we will move to the problem solving for this week. Like I said, we have a lot more questions today, so we will quickly move into that, and as part of that we will recap some of the concepts. And some of these are from week 11 also, so it should be easy for you. Okay, this is a long question that's going to be valid for questions. The data is going to be valid for questions 1 to 7. So let's look through this. Consider a neural network with the following layer configurations for a 1000 class classification problem. We train using STD. Instead of passing the entire input dataset at one go, we iterate over the dataset, and for each individual input example, we perform the forward pass, calculate the loss, and then perform the backward pass to update the training parameters. The dimensions of the input image is 3 into 224 into 224. The layer specifications are as follows. So we'll do one thing, since there's a lot here, let's go to question 1 and come back in context of question 1 what we need, right? So question 1 says, what are the number of channels for the output image volume of layer 1? You have 4 options, 64, 224, 32 and 3. Now I'll go back to layer 1. So layer 1 is a convolution layer with 64 3 cross 3 filters at stride 1 and padding 1, and your input dimensions are these. So now you can think about what is going to be the number of channels for the output image volume. You can take a minute and let me know. I'll wait here for a bit and then go to the options. Okay, I'll go to the options now. You can take a minute and let me know when you have an answer. Okay, maybe you guys have forgotten. Let's do this one question and then we'll see how to solve the other questions. So the answer for this is 64. Why is it 64? And the number of filters is 64 for layer 1 and we have 64 channels. So if you remember last week in week 11 there was this diagram where initially remember you have 3 channels in the input image, right? And then you have a bunch of filters working over these, and again we discussed how the filters move, right? What is the stride going to be, how they sort of move like the sliding window over the image, and that basically changes your height and width of the image. But the number of channels, we discussed that if you have one single filter, you're going to combine all these 3 channels that are there and you will get one output at the end of it, right? So the number of channels for the output image is decided not by the number of channels in the input image, which is 3, but by the number of filters. So remember we had this diagram showing a bunch of filters, right, operating over these 3 channels, and at the end the number of channels that you have in the output is the same as the number of filters. If this is still not clear to you, please go look at week 11 and the convolution diagram that we have, right? That will help you understand. And that's why a lot of people get confused with this and say that 3 is the answer. But 3 is not the answer because you're going to combine all those channels into one at the end of the convolution operation. So the number of filters which is given to you as 64 decides the number of channels in the output, and that's why the answer is 64 here. So hopefully this helps you understand this part. So a lot of questions today are very similar to this. This is a typical question that you will get asked in the neural network portion, which involves your understanding of various layers and how they operate over images. So we'll be doing a lot of questions in this pattern. So don't worry if you don't understand yet. Hopefully by the end of this session you'll understand. So let's go to the next question, unless you have any doubts here. I'll just pause for a little bit. Okay, let's move to the next question. The next question says, what is the height and width of each image in the output image volume of layer 1? And you have 4 options. So I'll go back to layer 1 for a bit. So your input dimensions is this, and your layer 1 has 64 3x3 filters at stride 1 with padding 1. You are asked about the height and width of each image after layer 1. Take a couple of minutes to solve this and we'll again look at the answers. I'll move to the options. Okay, we have one answer, D. Okay, one more saying D. Okay, let's take a look at the answer. It is D, that's correct. Let's see how we get D. So, like I always say, there are two approaches to do this, right? One is to use a straightforward formula. So, the formula is 1 plus either H or W, depending on whether you're trying to calculate height or width, minus F, which is your filter size, plus 2 star P. P is padding here, and then the whole thing divided by S. S is your stride. And remember, in this example, padding and stride were both 1 and your filter size was 3 cross 3. So this formula will evaluate to 224 minus 3 plus 2 divided by 1. So this is basically, there's a minus 1 here which cancels out with this and you get 224. So essentially, the same formula will work for the width also. Nothing changes there because your padding is the same, stride is the same, filter size is the same, and your width also is the same. So your width is also 224 and the output is 224 cross 224. Now, like I always say, if you forget this formula, or if you feel that you can't remember these formulae, a good way to do would be to take a smaller image and try out moving a filter with a small padding and stride, right? That will automatically tell you how you get to this, right? So for instance, first start off with padding and stride as 1. So you'll quickly see how you get to this 1 plus H or W minus F, right? And then once you add the padding, think about what changes. Similarly, when you change the stride, you'll be able to reason about what happens and come up with the same thing on the fly. That will also give you the same answer. Okay, hope this is clear. And again, just as a quick recap, padding is the layer of zeros that you add around the image. So if I say padding equal to 1, it basically means that I'll be adding one row and one column of zeros around the image. And stride means that that's by how much I'm going to move the filter. So if I say stride of 1, that means that each time I'm going to move to the right by one column. Similarly, I'm going to move below by one row once I finish this entire row. So that's your padding and stride. Hope this is clear. Let's move to the next question. What are the number of channels for the 3D image? Okay, let's go back. Changing the size of stride changes size of number of channels. No, it won't change. It would change the height and the width. So basically, stride and padding affect how your filter moves over the image, right? How fast or by what spacing it's going to move over the image. So your height and width will change, but your channels completely depends on number of filters you have. So that will not change. Okay. Any other questions? Okay, let's move forward. What are the number of channels for the 3D image volume for the output of layer 2? And you have 4 options: 64, 32, 16 and 8. So let's go look at layer 2 again now. So layer 2 is the max pooling layer with 2 cross 2 filters at stride 2. So remember that here you have to keep track of what is the output at the end of each layer, because that will be the input to the subsequent layer. So you have to think about what is the input to layer 2, what does layer 2 do, and then you'll be able to reason about the output. So this question asked us how many channels are there at the output of layer 2. You can take a minute to think about this. Let's move to the options. We have one answer A. Okay. Anyone else? Okay, let's look at the answer. It is 64. So let's think about why that is. So first of all, like I said, you need to keep track of what is the output of layer 1. So remember that the height and width did not change. It was 224 into 224 and the number of channels was 64, which was your number of filters. So your input to layer 2 first of all is 64 into 224 into 224. Now layer 2 is a pooling layer, right? Let's go back here. It's a max pooling layer, which means that, so this basically has filters of a certain size operating at a certain stride. So if you remember, there are two different types typically of pooling layers. One is your max pooling and the other is your average pooling. So it takes a particular window and performs either an average operation or a max operation. So let's say I have 1, 2, 3 and 4 here, right? And this is a 2 cross 2 max pooling operation. So you basically replace this by the max of that entire neighborhood 4 and then move to the next window. That's how the max pooling operation works. So here this will not change the number of channels at all. It will change the height and the width of the image for sure, but it does not change the number of channels. So the number of channels was 64 before this pooling layer. It would be 64 after the pooling layer also, and that's why your answer is A. Hope this is clear too. Okay, let's look at the next question. What are the heights and widths of each image? Okay, what would be the change in... that's your next question. So let's come there after we solve this. What are the heights and widths of each image in the 3D image volume for the output of layer 2? That is the same, your max pooling layer. So think about this, right? I just described the max pooling operation to you. So try this out on a very small image and then see what you come up with. We have one answer B, but I'll give a couple of minutes for people who are trying to solve this. This one is relatively simple because you don't have a padding and the stride is 2. So if anyone wants a description of layer 2 again, yeah, this is your layer 2. It's basically 2 cross 2 filters at stride 2. Yeah, you can take a minute more. B, okay. Let's look at the answer. Yes, it is B, 112 cross 112. So let's think about this. This is a pooling operation with a 2 cross 2 window size and a stride 2. So let's take a very simple, maybe a 4 cross 4 matrix, right? So we have 4 rows and 4 columns. So think about how this would work. Your first position of the filter would be these 4 elements, 2 cross 2 size, and then, like I said, you're doing the max operation over that, and you put that element as the first element here. Now the stride is 2, meaning that it jumps by 2 columns, and then this becomes the next window, and again you take the max and put it here. Then again you don't move by one row, you move by 2 rows. In both directions the stride is 2, right? So you do this window and this window, and then you get 2 more elements. So you can basically see that both are reduced by a factor of 2 here. This is again doing it from a logical perspective. You can also try and come up with a formula for this, and that would also give you the same. But ultimately the input was 224 cross 224. Now we are not looking at the channels, we are looking only at the height and the width, and both dimensions will see a reduction by a factor of 2 for the reasons I just explained, and therefore you will get your answer as 112 into 112. What would be the case for 2 cross 2 for stride 1? So basically in each row you will have this, right? You will have it moving by one column. So you can try and figure out what that would be in both for this question as well as if you write it as a formula. I think we will have questions that answer that also. So let's try to finish this entire set, and if we don't find it, we'll come back to that. It's fairly easy to solve. You're basically going to do this much, right? So it'll be very similar to your convolution formula in that sense, because in both cases you're doing the same windowing operation. Okay, let's move to the next question. What are the dimensions of the 3D image volume produced by layer 4? So let's go back to layer 4. By the way, we didn't do anything with layer 3, but you'll have to keep that in mind too. So layer 3 is a convolution layer with 128 3 cross 3 filters at stride 1, padding 1. Layer 4 is a max pooling layer with 2 cross 2 filters at stride 2. I'll pause here for a few seconds and then we'll go to the options. Okay, we'll go to the options now. Yeah, this was the question. So what are the dimensions of the image volume produced by layer 4? Okay, we have one answer, C. We'll wait a bit more and then discuss. If you need any information from that first slide, please let me know. I can scroll back there. Okay, we have one more answer, 3. I mean C. Okay, let's look at the answer. So the answer is C, 128, 56, 56. Let's see how that was. So first, we knew that after layer 2, the output was 64 into 112 into 112. Now after this, there was a convolution layer, and that was a convolution layer, again similarly 3x3 filters at stride 1, padding 1. Now if you very quickly think about this formula, 1 plus, no matter what the height or the width be, if you have 3 as your filter size, 1 as your padding, and stride also as 1, so the 2 star padding becomes 2. So this is basically 1 plus x minus 1, which becomes x itself. That's why in this case also the width did not change, width and height did not change. Similarly here, the width and the height do not change after this convolution layer, again because of the way that convolution layer is structured. Channels may change because the number of filters was different, but now we are only concerned about the height and the width. Okay, we are concerned about channels, height and the width. So remember that this convolution layer changes the channels to 128, but the height and the width do not change. So that remains 112, 112. Next you have a pooling layer, again a very similar pooling layer. Same 2x2 filters at stride 2. So you already know that this is going to reduce your height and width by 2, right? So you had 128 into 112 into 112. The channels is going to remain unchanged because pooling layer does not touch that. The height and the width is going to be reduced by a factor of 2. So that becomes 128 into 56 into 56. That's your answer. Any doubts here? Okay. And going back to the previous question, I think it's pretty straightforward. But if you had a pooling layer with a different stride, right, you would basically use this formula itself. Like I said, the windowing action is the same. So in that case, for instance, if you have a 2x2 filter here, right, and you had a stride 1, you would get a reduction by a factor of 3, I think. So basically you will just have to substitute your S here as 1, right? 1 was this one, and you don't have a padding, so it will be basically 1 plus whatever your height and width was minus your filter size, which was 2, and that's about it. So that would mean your this size will reduce by 1, right? So whatever that formula is, you can use it depending on the stride and the padding. Okay, we'll move to the next question. Any other doubts? Okay. After the linearization process post layer 13, what is the total size of the 1D vector passed to the subsequent fully connected layer in layer 14? So here you have to be a little smart. Such questions are also asked typically, right? So you have a lot of layers in between. So you'll have to see how to figure out when things change and when things don't change rather than blindly calculating everything. So we did up to layer 4. Now you are asked about layer 13. After layer 13, which is a max pooling layer, after this, what is the final size of the 1D vector which is passed to the subsequent fully connected layer? So here it says after the last pooling layer, the 3D volume of dimension CHW is linearized into a 1D vector comprising CHW elements and fed to the following fully connected layer. So basically, it's just like multiplying the three dimensions that are given to you. But you'll need to figure out what happens in all of these layers to get here. So yeah, you can. I'll pause here for a little bit and then go to the layer 11, 12, 13, and then to the options. I know this is a lot of calculation, so but try to do it smartly. This is where you spend a lot of time on one question, right? See how you can do it in a quick way. And we already discussed what doesn't change when. So that is kind of a short circuit through this path, right? So you'll be able to use that to do this. Okay, I'll move to the next slide. In case you need any layer description, just put that in chat and I can scroll back. Okay, we'll move to the options now. So this was question 6, I think. 5, yes, this was 6. So here are your options. If you missed some layer or you want to look at it again, please let me know. Yeah, option A, okay. Anyone else? I'll give you a minute more. Okay, let's look at the answer. It is option A, 25088. Let's see how we get here. So after we did the layer 4, and layer 4 the output dimensions was 128 into 56 into 56. Now we have a lot of convolution and max pooling layers here, right? We have two convolution, one max pooling, again two convolution, one max pooling, two convolution, one max pooling. So if you solve one by one, this will take you a lot of time. But here's what you have to look at closely, right? So we already looked at exactly this pattern, 3 cross 3 filters at stride 1, padding 1, which fits every single convolution layer here all the way till 12. Similarly, your max pooling layer with 2 cross 2 filters at stride 2. So you already know two things about these two layers. One is that here in these convolution layers, the width and the height of the image is not going to change. All that will change is the channels, which is going to be equal to the number of filters. That's true for all the convolution layers. Similarly, in the max pooling layers, you know that the number of channels is not going to change. The height and the width is going to reduce by half. So here is what we use to solve this question very quickly. So this is what I meant by your time management. So yeah, so successive convolution layers change only the number of channels. So number of channels after layer 13 would be 512. So you can quickly look at this part and figure out the number of channels. So here it becomes 256, here it becomes 512, remains 512 here, and the pooling layer here does not change anything. So number of channels is going to be 512. And similarly, convolution layers here don't change any height and width, and your pooling layers are going to divide your dimension by 2 each time, and there are 3 such pooling layers, right? So you know what your input size was 56 cross 56 initially. That becomes 28 cross 28, 14 cross 14, and finally 7 cross 7. And finally, after this max pooling layer, remember that there's a linearization step where you convert it to a 1D vector. So now you have 512 channels and the height and the width is 7 cross 7. So the size of the 1D vector would be 512 into 7 into 7, which is 25088, which is your option A. I'll pause here for 30 seconds or so. Take a good look at it. Make sure you understand it. If you have any doubts here, please ask me. Okay, if not, we'll move to the next question. One second. The assignment question, given padding equal to same. Uh, can you point me to which assignment question this is so that I can take a better look at it? I'm not sure. From what you week 12, okay, and question number 125, 127. Okay, I'll do one thing. I'll take a look at the question in the 5-minute break that we'll take around 7, and I'll let you know if it's clear to me. But same seems a bit ambiguous. I don't know same as what. So if I'm not able to answer it, then I'll kind of tell you to ask on the discussion forum. But let me take a look at the question once. I'll do that and then let you know. Okay, we'll do one more question and then take a break. Since this data is common to all 7 questions, let's finish that off. So, what are the dimensions of the weight matrix pertaining to the fully connected layer in layer 15? So, you have four options, but let's go back. So, I think layer 13 up to 13. So, 14 and 15 are both fully connected layers with 4096 hidden units. So, that's all I think you need from there. So, yeah, these are your options. Let me look at your assignment. Um, any answers? Okay, let's take a look. I think this should be fairly straightforward, but since this is the first fully connected layer we're doing, let's discuss it. So, the dimensions of the weight matrix are 4096 cross 4096. So, this is asking about layer 15. So, again, we need to know what is the input to layer 15. So, before layer 15, there was a layer 14 which is also fully connected and had 4096 hidden units. That implies that the input vector to layer 15 would be of dimension 4096. Now, layer 15 also has 4096 hidden units. So, basically, your weight matrix will be this size 4096 cross 4096, because this is a fully connected layer. So, it would depend on your number of hidden units and your input vector size. And dimensions are 4096 into 4096. I think this is straightforward. We'll stop here. So I took a look at that question. It says padding equal to same indicates that zero padding is used to match the size of the output matrix with the size of the input matrix. So this means that the way I understand the question at least, it means that padding is something that you have to figure out, and the question says that the padding is set so that the input matrix size and the output matrix size remain the same, right? So if you are given other things, for instance, I think here you are given the filter size, you are given the stride, you are given the channels, and you are given the input image dimension. So using this formula that we have discussed in class, you will be able to calculate what is the value of padding that will give you the same size at the output as the input, right? So that's, any more than that if I tell you, I think I'll be solving the question for you, which I'm not allowed to do, but hopefully that makes it clear. Great. Okay, so I think this is a good point to take a break. So it's 6:55 5, we'll resume at 7. We have, I think, another 7 or 8 questions to do. So, yeah, see you in 5 minutes. Okay, let's continue. So this is a different set of questions on your CSR format. So you have this sparse matrix given to you. Assume that this is stored in a CSR format. What is the length of the vals array which stores the non-zero values? I think this is fairly easy. One second, okay. Which question is this again? I don't see a 64 by 8 anywhere here. Okay, in your assignment. Let me take a look. So this is the same question 1, is it? Okay. Let me open that up and look at it while you guys are solving this. Let's do that. Yeah. So what is the length of the vals array which stores the non-zero values? Okay, we have one answer, B. Anyone else? Okay, let's take a look at the answer. It is 6. So why is it 6? Remember from the recap, so the way we'll come back to a detailed recap after we do 2 more questions around CSR. But your val and call arrays are of length n and z, which represents the number of non-zero values in the matrix. So here your vals array is asked, so the length is basically the number of non-zero elements. So you have 1, 2, 3, 4, 5, 6 elements in this matrix, and that's why your answer is B. Hope this is clear. I'm looking at the question, so I see 2 fully connected layers, and one says 64 neurons and one says 8 neurons. So what is the doubt again? What does that mean, is it? So a fully connected layer is basically like this one that we discussed, right? You have a certain, every neuron is connected to every other neuron basically. So that's how you understand this 64 and 8 that are given to you. And before that I see this pooling layers and convolution layers. And yeah, I think that's fairly straightforward. So that basically tells you what, so fully connected layer means that everything is connected to everything else, right? So if you have 3 from the previous layer and 2 here, it means that this is going to be connected to this and this is going to be connected to this and this is going to be connected to this and this. So based on that, you will need to figure out your dimensions. So for instance, if the dimensions of the weight matrix are asked, like just the way we did here. So we know that the input vector to this is going to be of a certain dimension, and we know how many hidden units or neurons are here, and therefore we know what the dimensions of the matrix are. So you should ask yourself what the dimensions of the weight matrix should be if I am supposed to connect some m things to n things. That's it. What that m and n would be depend on the particular question, right? So that you will have to figure out. Okay, hope this question is clear too. Okay, we'll move to the next question. For the same sparse matrix in question 8, what is the length of the call array which stores the column indices of the non-zero values? This is also fairly straightforward. Anyone? Okay, let's take a look at it. So again, going back here, the arrays call and val are of length n and z. This is the number of non-zero elements, which in this case was 6. Even if you don't remember that, if the definition is given to you in the question, right, that makes it much easier. So read the question carefully. So here it says length of the call array which stores the column indices of the non-zero values. So by default, if you just read the question, you'll know that the indices of the non-zero values are stored. How many non-zero values are there? 1, 2, 3, 4, 5, 6. So the answer is again 6. Okay, we'll move to the next question. Any doubts in this? We'll move to the next question. For the same sparse matrix, what is the value of PTR2? 3, 4, 5, 6 are your options. I'll move to the matrix so that you can figure this out. So this is your sparse matrix. You're asked for PTR of 2 and your options are 3, 4, 5 and 6. I'll go to the options. You have one answer, A. Okay. Let's take a look. This is also easy. So it is A3. So what does PTRI store? It stores the number of non-zero elements seen up to ith row. So here we have PTR of 2, meaning that it stores the number of non-zero elements seen up to the second row, right? So that would include the second row as well. That's where most people get confused. So these two rows basically. So you have 1, 2, 3 in this row, none in this row. So overall your PTR2 would be 3. Any doubts here? This is the last question on CSR. Again, this is also a frequently asked thing, right? So make sure you understand the CSR format, and this is not too complicated. Once you understand what are these three things, what do they store, either you will get questions like this which ask you for the values of one of those, or you may be asked to construct the matrix given these things, right, which was also explained in a course lecture video to you. So both those kinds of questions I think you'll be able to solve. Just make sure you understand the concept well. Okay, if there are no questions, we'll move to the next set, which I think again is about the neural network dimensions. Okay, so again, this is going to be common for the next 5 questions. So we'll go through this. Consider a neural network with the following layer configurations for a 1000 class classification problem. Train using stochastic gradient descent instead of passing entire data set. Iterate and pass each individual input, perform forward pass, calculate the loss, perform the backward pass. Dimensions of the input image 3, 227, 227, and layer specification is as follows. Con 1, 96 11 cross 11 filters at stride 0, padding 0, max pool 1. We'll come back to this, right? We'll go to the questions and come to this. So after the last layer, the image volume is linearized and fed to a fully connected layer that would yield a vector of 1000 class scores. Basically, because you're trying to do 1000 class classification. The possible intermediate dimensions of the outputs of each layer are as follows. So you have 6 options here. So your first question is, what are the dimensions for the output of con1? So you have to pick the dimensions from the previous set given to you, this, right? So I'll go back to this set, and con1 is a convolution layer with 96 11 cross 11 filters at stride 4 and padding 0. So you can solve this and then we'll discuss the answer. This is very similar to the previous question we solved. So you can take your time and let me know which of these answers is the output dimensions of con1. That's your question currently. Okay, we have one answer, 96, 55, 55. This one, okay. Anyone else? Okay, let's take a look at the answer. It is 2, which I think is, yeah, 96, 55, 55. Let's see how we get there. So input image size is given to you as 3, 227, 227. And filters description is, we have 96 filters which are of size 11 cross 11, stride 4 and padding 0. So you're asked about the output dimensions. So the easy thing is the number of channels is going to be 96. That in this case helps you eliminate all of these. So you just have to look at these two. But anyway, let's see how you get the height and the width also. So you can use the same formula as last time, which is 1 plus your height or width, which is 227 here, and your filter size is 11. 2 star p, but p is 0, so this goes away, divided by s. S is 4 in this case. So 1 plus 227 minus 11 by 4. So you get this to be 55, and similarly the other dimension is also the same. So your output would be 96 into 55 into 55, which is your B or 2. I'll pause here for a little bit. Go through this. If you have any doubts, please ask me. Like I said, this type of question is fairly common. So it's good that you understand how to solve this. Okay, I'm hoping that is clear. Dimensions of output of conv2. So let's go back. So conv, before that there's a max pooling layer. We just looked at this one. The conv2 is basically 256 5 cross 5 filters at stride 1, padding 2. So again, very similar question. Take your time to calculate it. So the max pool doubt that someone had about the stride is here. So you'll figure it out while you solve it. Oh no, maybe that was not the doubt. A doubt is probably not in this question, but yeah. Okay, we have one answer, 3. This one, okay. Anyone else? 3. Okay, let's look at the answer. It is 3. So let's see how we get there. So first, the input to con 2 is the output of max pool 1. So we had already solved the con 1 layer, and this has dimensions 96, 55, 55. And then you have a max pool layer with 3 cross 3 filters at stride 2. And this is going to give you 96, 27, 27. This is a mistake. It should be the same, 96, 27, 27. So for those of you who are wondering if I have an odd number of, basically if I have something like a 3 cross 3 matrix and I have a filter of size 2 cross 2, so this is going to span 2 rows. So it can take 2, and the stride is 1, it can take 2 steps, but the third step will basically go outside the matrix. So in that sense, even if it's an odd number, it's ultimately going to give you, it will basically be like floor of that. So here, even though you have 55, you will get only 27, not 28, if you are having that doubt. So anyway, so the max pool output would be 96, 27, 27. Now you are asked about conf 2, so you simply use the knowledge that you have. Channels, number of filters is 256, so the number of channels would be 256. Filter size is 5, stride is 1, padding is 2. So the divide by 1 you can kind of ignore. So 1 plus 27 minus f plus 2 star p, this will become 4, and f will be 5. So 1 plus 27 minus 1, which is basically 27. So the width and the height don't change. So 256 into 27 into 27, which is your 3. Again, I'll pause here for a bit. Take your time to go through it. And if you have a doubt, please ask me. Okay, we'll move to the next question. Dimensions of output of max pool 2. So let's go back. Max pool 2 is 3 cross 3 filters at stride 2, right after conf 2. So again, you can tell me which one that is. Okay, we have an answer 4. Anyone else? 4. Okay, let's look at the answer. Yes, it is 4. Why is it 4? So again, conf 2's outputs are 256, 27, 27. Max pool will not change your filters, which will remain at 256. Now for the max pool, stride is given to you as 2, filter size is 3. Again, like I said, you can compute the dimensions using the same formula, right, that you used for convolution. So 1 plus 27 minus 3 divided by 2, which you get to be 13. So the width and the height are 13, and your dimensions are 256, 13, 13, which is your option 4. So this is your right answer. I'll pause here for 30 seconds and then go to the next question. Okay. Dimensions of output of max pool 3. So we did max pool 2 now. So we have three convolution layers and then finally a max pool 3. So take your time to look through this. Okay, we have one answer as 6. Okay. Anybody else? Okay, let's discuss the answer. Yeah, we are looking at 14. Yes, it is 6. So between max pool and max pool 2 and 3, we have three convolution layers, but all of them have p equal to 1 and s equal to 1. Basically, as we saw in the previous question also, the height and the width of the image remains unchanged. Why is this? If you work out with the formula, you will get to know. So that means that earlier we had 13 cross 13, which will remain the same, right? In this question we had the 256 13 13. So the 13 13 will not change across the convolution layers. The number of channels will change, and the number of channels is going to be 256 at the end of this. So that would be your input to the max pool 3. Then after max pool 3, which is again 3 cross 3 filters at stride 2, if you calculate the output of this, you will, the number of channels remains unchanged, it will be 256. This 13 cross 13 will become 6 cross 6, and that is your option 6, 256 into 6 into 6. We have one more question in this set. I'll just wait here in case you have any doubts. Okay, let's move to the last question. What are the dimensions for the weight matrix in the last fully connected layer? You have 4 options here, so this is not in the 1 2 3 4 5 6. Let's go look at that fully connected layer first. So after max pool 3, we just solved this one. The image volume is linearized, so this is similar to the previous questions operation. And after that, it's fed to a fully connected layer that would yield 1000 class scores. So you're asked about this now. Yeah, Take your time to think about this. We have two answers A. Wait a few more seconds. Okay, let's look at the answer. Yes, it is A 9216 in 2000. How do you get this? So output of max pool 3 is linearized. So you had 25666, you multiply all three, you get a 1D vector or an array, which is 9216, and your output is supposed to be an array of 1000 class scores. So that's the M and the N that I was talking about, right, for a fully connected layer. So depending on this, you would get the dimensions of the weight matrix. So hopefully this helps you with the assignment doubt that you had also. So, and that's why the answer is 9216 into 1000. Hope this is clear. Okay, I think this is the last question we had for today. So this will be the last live session. So if you have any further doubts, if it's an assignment or an exam specific doubt, you can again ask on the discussion forum. The regular TAs will get back to you. There's something else regarding the live sessions you want, again you can ask on the discussion forum and I'll reply to it. If you have any feedback on the live sessions format, etc., you can also mail me. I've left my email ID here. And thank you for joining all these live sessions and good luck for your exam. Hopefully you've benefited from these. So thank you so much. Any class or information? Not really. Information, I think. Negative marking, again, I don't think so, but any exam related stuff, it would be good if you can ask on the discussion forum. Since I'm neither involved in setting those questions or evaluating them, I will not be able to comment very specifically. From what I know, there is no negative marking and it's typically just MCQs. There is no subjective question or things like that. But again, all of these things, what I know may or may not be correct, right? So it's good you ask directly on the discussion forum. There is no class as such related to the final exam because again they are expected to be very similar to the questions that we've already discussed. So this would be the last live session. Any other questions? Sure, you're welcome. Thank you so much. Okay then, thank you and we'll end today's session here.